And we're back and better than ever. We are now in Chapter 7, Ionic and Metallic Bonding. In 7.1 we're going to be dealing with ions, in particular, why do ions form? We did talk a little bit about this in Chapter 6, but now we want to get into a little more detail on why the ions will, or why the atoms will either gain or lose electrons to form positive or negative charges. Alright, so the first thing that we want to review is the idea of valence electrons. Valence electrons are the electrons in the outermost energy levels. That is to say, they're in the energy levels, or the highest energy levels, technically speaking, as opposed to what are called core or kernel electrons. The core or kernel electrons are electrons in lower energy levels. All right, now, recall from brief discussions in Chapter 6, it's very easy to tell which electrons are going to be valence and which ones are going to be core. Everything up to the previous noble gas is going to be considered core or kernel. Everything after the previous noble gas is going to be considered valence. Here's a few examples. When you're dealing with helium, helium does not have a previous noble gas. It's in the first row. So both electrons with helium will be considered valence. Neither of them are considered core. That would be 0. Now with lithium, as soon as you get past helium, those two electrons are now in the inner energy levels, or lower energy levels, and lithium has just one valence electron. Looking at the periodic table, it's just simply one electron past the previous noble gas. Oxygen, which has a total of 8 electrons, the first 2 electrons are in the first energy level. The next 6, count them across from starting with lithium all the way across, the next 6 are considered valence. They're in the highest energy level, the second energy level. When you get to magnesium, magnesium is in the third row. Everything up through the first and second rows, the first and the second energy levels, are considered core. So magnesium has 10 core or kernel electrons. The 2 electrons that it has in the third energy level would be considered valence. So it's very easy. Just simply start on the left-hand side of the periodic table and count across S and P electrons are going to be your valence electrons. Aluminum. Aluminum is one past magnesium. It still has 10 electrons in the first and the second energy levels. It has 3 electrons in the third energy level. So it has 3 valence electrons. Chlorine, which is all the way over in group 17 or 7A, it has 10 core electrons, and then starting from the left, as you count your way across the periodic table, it has 7 electrons in the third energy level, so it has 7 valence electrons. When you get to potassium, potassium is starting a new row. It only has 1 electron in that fourth row, but it has 18 electrons in the first, the second, and the third energy level. All right, so that just gives you a little snapshot on how you can count core and valence electrons. Now we use electron dot structures, which are diagrams that show electrons as dots around the atom. And so if we go back up here to our diagram or our table here, helium has 2 valence electrons. So we can put 2 dots next to helium, and that would denote the 2 valence electrons. Lithium only has 1 valence electron, so we put 1 dot next to the lithium. Oxygen has 6 valence electrons. The way we typically do it, we'll go around the atom once, so 1, 2, 3, 4, and now you can place the other 2 dots next to one of the other dots. So that would be a total of 6 valence electrons. Magnesium only has 2 valence electrons, so we can put either one on each side or one on top and one on the side. That would be fine. Aluminum has 3 valence electrons, so I'm just going to put one on the left, one on top, one on the right. Chlorine has a total of 7, so I'm going to put 1, 2, 3, 4 going around, 5, 6, and I'll just put the other 7 one down there, and that gives it a total of 7 valence electrons. Potassium only has 1 valence electron, so I'm going to put 1 dot there. And that's all there is to it, to writing electron dot structures, is just simply putting dots around the atoms. You try to put one around each side first and then start doubling them up. This oxygen is just a little bit awkward the way I wrote it up here. Most people will put the dots right next to it, something like that. And then the next 2 on top will go like that, and then you have one on the bottom and one on the side. So you try to make them symmetrical, or you try to make them nice and neat around the edges. You don't just randomly place them around. Usually they have 2 on top, 2 on each side, and 2 on the bottom when they're completely filled. As I scroll down here, you will see some dot structures, and you'll see how neatly we do try to place these around the atom. Now, there is not necessarily an exact location once you start pairing them up. For example, if you take a look at this nitrogen, most people would in fact put that 5th electron up on top, but there's nothing to say that you can't put it off to one of the sides either. And in fact, depending on the structure that you're going to draw, some people will move them around. But the basic idea is that you want 2, you can't have more than 2 on each side, and you always put 1 around each side before you start pairing them up. Helium is an exception because there's only 2 electrons that are allowed in helium. And so they place them together, but that is definitely the exception to the rule. What a guy by the name of Gilbert Lewis noticed in the early 1900s is that atoms will tend to lose or gain electrons to achieve 8 electrons in its outermost energy level. And it's called the octet rule. Again, what he observed is that metals tend to lose electrons to achieve, I should say achieve there, noble gas configurations, while nonmetals tend to gain electrons to achieve noble gas configurations. Configurations. There we go. That's an S right there. What do we mean by noble gas configurations? If you notice, besides helium, all of the noble gases have 8 valence electrons. And so the octet rule, octet meaning 8, simply means that atoms will either lose or gain electrons so that they have 8 electrons in their outermost energy level, or their highest occupied energy levels. Okay? Now, in the next podcast, we're going to show some diagrams that illustrate how this actually works. We'll see you next time.